Hey, Boyne City Middle School. Welcome to day 2 of our fossil lab. We're going to take a look at stations 11 through 20 today. So grab your shovel, grab your fedora, your hiking boots, and here we go. Station 10 we left off at an ammonite, and station 11 is, guess what? More ammonites, except now you actually get a sense of what they really look like from the side view. Station 10 had a fossil ammonite from a side view like this, and it didn't really look like much of anything. But now when you look at an ammonite from the side, you get to see that this is something kind of snail-like. And specifically, if you did your research on Station 10, they're actually kind of related to the squids, except they have this really cool, beautiful spiral pattern shell. So question 11, why do you think these two ammonites look so much different from each other? So I'm asking you to make an inference. We have a similar pattern, but if you notice, very different coloration, brown on the left, black and white on the right. And then based on the fossil evidence, where did the first life evolve? And it's the last part of question 11. If we go back to our geologic time poster, once we get beyond about 270 million years, and that puts us in the Paleozoic era, take a look at those images. We've got nothing but fossils that come from the ocean, don't we? So that wraps up station number 11. Moving on to number 12 is another fossil donated by retired teacher Dale Thomason. So I thank you for that, Mr. T. And he used to work and teach out in Saudi Arabia when he was younger. Went for a hike one day and he found this incredible fossil cast of a snail. And this snail was not terrestrial, it was marine. And he was on a desert mountain in Saudi Arabia when he found it. My question for station 12 is, if you need to Google it, go ahead. If you know them by memory, what are the 3 basic types or categories of rock? And of the 3, where do we find fossils? Which of those 3? The other 2 we don't, but which category? And this would be included among them. Where do we find fossils? That's station 12. Station number 13 is a beauty. Put it under the lamp here so you can see the detail. There we go. And although I didn't dig this one up myself, you could. These little rascals can be found out west in Wyoming. And this is a beautiful example of a fish backbone showing up in the fossil evidence 400 million years ago. And when you look on the poster, I'd like you to we're going to find the oldest fish. This one happens to be named Priscacara. And we're going to take a look at our poster now. Off we go. So over 400 million years ago, that puts us in the Paleozoic. And so here we are, 400 million years out, between the Devonian and the Silurian. We follow it across. And hello there, Eustenopteran. Some of these names are pretty crazy. But when we scan down, at least on this poster, that seems to be the oldest fish. Not the most famous fish by any means. You've probably heard of the coelacanth, the quote-unquote living fossil. That's kind of interesting too. But if we come back to our fish at station 13, I'm asking you, what living fish is Priscacara related to? So maybe this is a common ancestor to a modern day fish. What would it be? So you're gonna have to Google that one. I mean, you're welcome to guess, but I have the feeling if you Google that you'll be successful in finding its closest living relative. And that wraps up station 14, or excuse me, 13. Yep, just double checking. And station 14. During the Carboniferous period, most of what is now eastern United States was a big old swamp. What type of plant was this 280 to 300 million year old fossil? Research what type of fossil fuel was formed during the Carboniferous. So that last part of question 14 is just on your own Google research. But when you look at these trace fossils, left impressions in the stone, what do those plant shapes remind you of? Very common plant back in the Carboniferous, dominant plant to be specific. All right, station number 15, later on in the Carboniferous. It's a beauty there. There we go. Later on in the Carboniferous, plants evolved to make wood. So in other words, the first plants did not make wood. This helped them grow taller, and these petrified wood samples happen to be from Africa. I had to buy them in a catalog. And I'd like you to look at consider two pieces of evidence that suggest fossilization is a chemical change. And, if you look at this from the side, it still has the same color of wood, but look at the middle. Wood is not that color. And some petrified wood colors like this one really take off and go a different route. This one is a beauty, isn't it? So you see some reds and yellows and even grays that are not indicative of modern living wood. So we have a color change suggesting chemical change, and also it's rock. It is no longer wood. You could verify that, and we will at station 16. So if it feels different, it feels heavier, like it isn't wood anymore, it has been changed to a type of stone. So we're going to prove that by checking the density. We know that the density of wood most of them are less than 1 because they float. So I'm going to have you write down these two numbers, and then you're going to do the math on your own. The mass is 148.1 grams for a piece of petrified wood, and the volume, we're starting at about 155, it looks like, a little less than 160, and it goes up to 155 to 210. So what's 210 minus 155? That's gonna be 55 milliliters. So the volume is 55 milliliters. Divide mass by volume, get your density, and you'll find the density of that petrified wood is not the same as wood from a tree that is currently living, or was currently living, and that is station 16. Evidence that there has been chemical change during mineralization. Station 17. This is considered a small dragonfly. It's a plaster cast of an actual fossil. Some fossils are so expensive, I can't afford to buy them. But there have been in the fossil record examples of massive dragonflies. Its anatomy, similar to modern dragonflies, even though this thing is tens of millions of years old. And just for a little bit of practice, we're gonna get the average length of the wings. So follow along here and divide the following four numbers. Looks like we have 4.5 plus 4.3 plus 4.6, and the last wing is 5.0. So could you please add those up hit equals, divide by 4, and get the average wing length for station 17. And then do a little Google research. What is the largest fossil dragonfly ever found? It's pretty hard to believe, but they found the fossil. That's station 17. Moving on to station 18. Here we are, a dinosaur footprint. And so tracks are evidence of a lot of different things. We can tell kind of how dinosaurs moved, if they moved by themselves, if they moved in herds. We can also get the relative size of dinosaurs. So station 18, this particular one is named Gralator, based on the size of the footprint and for how large this dinosaur was compared to modern day birds. And if you need a better sense of that, we're coming in at about 6 centimeters, 60 millimeters. So about we're looking at about 2.5 inches. So can you think of a living bird today that had a foot about that big? Oh, hey, look at that. That helps. What else is going on at station 18? Gralator was bipedal. And if you don't know what bipedal means, give it a quick Google search. What does bipedal mean? Because not all dinosaurs moved the same way. Let's cruise around to 19. We've got a plaster cast of the head of an ancestral bird. It's pronounced Archaeopteryx. And Archaeopteryx is in the Hall of Fame of fossils because it is a good example of evolution caught in action. We got something that is pretty much half bird and half dinosaur. These were found in rock quarries in Europe. And that is a plaster cast of an actual fossil skull found of Archaeopteryx. And to give you a sense of the size, this thing was, coming in 5.5. So it looks to be a little smaller than a crow maybe. And that's just the head. And I don't know if you can see it or not. I don't know if the plaster showed it, but these little rascals had teeth. So Google Archaeopteryx and take a look at the entire skeleton. There have been six to eight partial or complete skeletons of Archaeopteryx that have been found. And I'd like you to find some anatomical structures that make it similar to modern birds and write down 2 or 3 anatomical structures that make it similar to dinosaurs. This truly is a fossil link. It's a connection between the ancestral dinosaurs and modern birds. And although many other fossil links have been found in China, this was the first one that really got scientists excited and made them realize that birds are the descendants of ancient dinosaurs. And that is Archaeopteryx. Archae meaning ancient, pteryx meaning wing. So check that out. And then we'll finish up today with a gastrolith from a dinosaur that lived during the Mesozoic. First of all, what is a gastrolith? And check that out if you don't know. And how do living animals use gastroliths? Living animals, well, you're going to have to find out what living animals would have one and how they use them. And then tell me what can you infer from this? If dinosaurs had gastroliths and modern day animals do as well, what does that say about the connection between those two? One might wonder, how do you know this is a gastrolith? My suspicion is when they found this stone, they found it amongst a pile of dinosaur bones, and it was right there with the dinosaur bones when they dug them up. And then they realized, this has the same, very possibly has the same function as some modern day animals. That's going to wrap up our fossil tour of today, everybody. Hopefully things went well. If not, email me. Again, you do not have to turn in the work that you've done today. We're going to wait till the end of day 3. All right? Take care, everybody. If you get a little bit of time, go out and find a Petoskey stone. Take care.